again tomorrow because I really want y'all to be able to pay attention and not be writing constantly, okay? If you're at home and you did not have a printer, I will tell you what to write in your notebook. So I'm going to pause so I can pass these out. All we're covering today are the trigonometric ratios because this is like the base of everything trigonometry. If you don't understand the ratios, you won't understand anything else. So we got to make sure you're good with the ratios. And then we're going to go into finding missing sides today. And we're going to stop after these 6 examples. So the rest of this we'll do tomorrow, okay? Is everybody good? All right. If you tell your parents you're learning trigonometry, I told you this yesterday, but I'm going to say it again. They would probably have like a mini seizure because when they learned it, there weren't all these like super cool, easy ways to remember the different ratios. Okay? So when we talk about trigonometry, trigonometry is just a branch of math that helps us find the relationship between side lengths and angle lengths in a triangle. Okay? I know somebody, Chris would have asked, but he's not here. When will we ever use this? Do y'all know why we spend so much time in math on triangles? You want me to tell you? Okay, in the real world, the strongest structures are built with triangular bases. It's like, have y'all ever looked at a bridge and either like the wiring or the beams for the bridge make X's or triangles? Okay, an X is literally just 2 triangles facing each other. So triangles are the sturdiest of structures. So like even the foundation of houses, a lot of times they're triangular or in X's, which is again, just 2 triangles. Okay. So if you want to be an architect, engineer, anything like related to that kind of stuff, you will use this every single day in your job. All right. If you don't want to do that, you still have to learn it because you got to do it in college. Keydream's like, this is so dumb. I love trig. Like, it's not hard at all. I'm going to teach you a really corny, not greatly school-related saying. Like, you might get in trouble if you go home talking about the saying I'm going to teach you today, but it's okay because it's going to help you remember it. Jake's like, right on. You've caught my attention. Is everybody ready? Okay. So when we're doing trigonometry, the 3 trig ratios that we do in Math 2 are sine, cosine, and tangent. It's brand new. So if you're like, what the heck are these words? That is totally okay. It should be new. If you're at home writing, you're going to want to write each of these down. You can do 3 separate bullets. So sine, cosine, and tangent, those are our 3 trig ratios. So I'm going to highlight for my people at home that might be writing. Sine, cosine, tangent. All right, your symbols, it's not really a symbol, it's more of an abbreviation. Sean, make sure you're taking your notes, bud. So sine is S-I-N with parentheses. It is not sin. If you call it sin, I'm going to be irritated because I got pre-cal kids that'll talk about some sin. Not talking about your sins, that is sine, okay? Then cosine is not cos. If you see C-O-S, I'm talking about cosine. I need you to call it cosine, not cos. That's not even a real word. No, that is not an E. That's this little symbol down here. We'll talk about it in a minute. It's a 0 with a line through it. Yeah, that's a 0 with a line through it. Quit playing my E's like that looks just like those. It looks nothing like those. Oh, my Lanta. And then tangent is tan with that symbol in the parentheses. So let's go ahead and talk about that symbol because y'all are saying that they're E's and they're not. So the symbol that looks like a O with a line through it. Does anybody know what that's called? It's a Greek letter. Starts with a T. 12. That's a number. That ain't a Greek letter. Woo, no, that's a shape. Bless y'all. Theta? That's theta. It's a Greek letter, T-H-E-T-A, theta. They are. Oh my God, look at my people in the chat being smarties. So Riley and Keyshawn are saying, I've seen these buttons on a calculator before. Yes. So this is why some of y'all are going to like this. This is done in Desmos. You just have to know how to set it up the right way. Then you're going to go do the whole thing in Desmos or in a graphing calculator. I'll show you both, okay? Evan, you'll like this. So theta, hang on, theta is just the symbol we use to refer to angles. They're most likely not going to call an angle X or Y, okay? In trigonometry, they use Greek letters to represent angles. Why? I don't know. Big part of it could be the guy who like invented trigonometry was Greek. I don't know his name. We can look it up later. I'm not good with like names. I'm visual, so like I only remember y'all's names because I can see your face. All right, so the symbol theta refers to angles. So does everybody see this little theta right here? It's talking about the angle that's marked. So this is just angle theta, okay? So do y'all see how this whole section was titled trigonometric ratios? The definition for each of these is going to be a ratio based on this triangle over here. So before we write out the ratios, we got to name these three sides of the triangle because that's what this is pointing to. You should already know the name of the longest side. Hypotenuse. Very good. So everybody look, if you are at home, you're going to want to draw this. So draw a right triangle, label that angle down there, and this longest side we know is called the hypotenuse. Everybody okay with that part? Okay. Now, the other two sides yesterday, what did we call both of the other two sides? Legs. So now we're going to be more specific about what types of legs they are, okay? If you look at the angle, does everybody agree it's in the bottom right? Okay, which leg is touching the angle? Good, the bottom leg, this one. So who remembers from when we did angles, Sean? Who remembers from when we did angles what it's called when angles touch something? Starts with an A. Oh, y'all are making me sad. Who said that? Evan, extra credit, say it again. Adjacent. This right here is your adjacent leg. And it's adjacent because it is touching the angle. Psst, psst. Pick your head up. You don't want to sleep during this. She won't have time to relearn it later. So the adjacent leg is the side that is touching the angle they marked, okay? The side that's all the way across from it, the leg that's completely on the other side of it. Does anybody want to guess at what we call that? Okay, it is non-adjacent. It's all the way on the other side. An O. No. Opposite? Because it's across from it, like it's on the opposite side of the triangle. I mean, I said, do y'all want to guess it? And y'all said, sure. I didn't think you would get it. This is the opposite leg. The opposite leg is on the other side. So if the angle is in the right, the opposite leg will be on the left. Angle's in the top, opposite leg will be on the bottom. Very good. Anytime you're doing trig, you have to know if you were given the hypotenuse, adjacent, or opposite, because depending on what you have in the triangle they gave you, depends on which of these you're going to use. Are we okay with that? Okay, so let me write out your definitions for you. Whenever we're dealing with the sine ratio, we are always going to do the opposite leg over, because it's a ratio, so it should be a fraction, right? over the hypotenuse. So for sine, it's the opposite leg over the hypotenuse. Cosine is the adjacent leg over the hypotenuse. And then tangent is always the opposite leg over the adjacent leg. So remember, if you're at home, you're going to want to be writing these by your 3 bullets. And then you can have a triangle drawn off to the side. So while you're finishing writing, everybody listen. I'm going to tell you the 2 parts that like mess people up with trig so much. Knowing what I gave you in the triangle, because I bet you $5 in a second, somebody's going to tell me the one touching the angle is opposite. And then I'll be sad. Or you'll tell me the one that's diagonal and clearly the longest is the adjacent, and then I'll be more sad because that's the hypotenuse, okay? Y'all will not pay attention to your triangle and you'll label it the wrong things. Or back in the old days, people would mess up their ratios. Y'all won't mess up your ratios because I'm about to teach you a really corny way to remember it. Is everybody ready for the corniness? Are we sure? All right. You're going to write this at the top of your paper. You're going to write it in your notebook. Actually, let's do it like this. Some old hippie. If you don't like the word hippie, you can say homie. I don't care. That's fine. Some old homie, some old hippie caught another hippie. Write it just like I'm writing it. Write it just like I'm writing it. Which means old should be over hippie. Another should be over hippie. Some old hippie caught another hippie. You don't like the word hippie? You can replace it with homie. Tripping on acid. I told you it was not school appropriate, but you're going to remember it. Some old hippie caught another hippie tripping on acid. If you know that saying, you should never mess up your ratios. I want everybody to watch once we have it written. Is anybody at home still writing? Or am I good to keep talking? No. I learned it at college, believe it or not. When I was in school, they didn't have this saying either. They literally would talk about an Indian named Sakatoa. But who knows how to spell Sakatoa? Exactly. It was not. It wasn't. Nope, you're already wrong. It wasn't a good analogy. So everybody look. Some old hippie, what does the letter some start with? Or the word some start with? What letter? S. So which of these ratios do you think this part refers to? Sine is always going to be O over H, the opposite over the hypotenuse. If you can remember some old hippie, you will know that sine is always O over H. Is everybody okay? Okay, caught another hippie. If you can remember that C stands for cosine, you'll remember that it's always the adjacent over the hypotenuse. Caught another hippie. Cosine is adjacent over hypotenuse. And then tripping stands for tangent. On acid, O over A, that's opposite over adjacent. Are we okay? It's brand new. So if you're like, how the heck does this work? I'm about to show you, and it's not hard at all, but you got to remember those ratios. You got to know that saying. Keidreen, I hope you're paying attention, boo. They don't be doing cool stuff like this in New York. So they probably did. You might have heard this before. They did or didn't? No? All right, so everybody look, here's how we're gonna use this. You ready? Look at example 1. Find the trig ratios for the indicated angle. So where is the angle in example 1A? People at home, you can just watch on this one if you want, if you're writing, like if you're having to draw it out. Where's the angle at in example A? On the top. Very good. So let's go ahead and talk about this. You find where your angle's at. I need you to circle it. Circle your angle. Your next step, and if somebody needs me to write these out, I will. Circle your angle is step 1. Step 2, label all 3 sides. I need you to label the hypotenuse, the opposite, and the adjacent. Who can tell me what my hypotenuse is? 39. So this is going to be H. Which leg is adjacent to the angle? Be careful. 15. Adjacent means touching, so the 15 is touching. Now the opposite, if the angle was in the top, then that means the opposite will be the bottom. Good. So I'm going to repeat it again. Step 1, you're going to circle your angle. Step 2, you're going to label your 3 sides. Is everybody okay with that? So now that you have your sides labeled, you should be able to find your trig ratios. So let's review. Who said Sokotoa? So that's how your parents learned it, but they spelled it wrong all the time. It's Sohcahtoa. But they would spell it wrong. I used to spell it wrong because saw and cuh make the same noise kind of. So some old hippie, sign is old hippie. So what's my O? 36. What's my hippie? 39. Bada bing, bada boom. That's the sine ratio for the triangle. The opposite side is 36. The hypotenuse is 39. Now, can we simplify that? Yes, you can. 12 over 13. 3 goes into both of them is what I heard. Very good. So if they ask you for the sine ratio, that's it. That's the answer for the sine. You found your angle and you put the opposite side over the hypotenuse. It really doesn't get much harder. Yes, ma'am. Because it says find the trig ratios. What are your 3 trig ratios? Sine, cosine, and tangent. So you got to find all 3. Yep. So sine is the opposite over the hypotenuse because it's some old hippie. So how do we find cosine? Caught another hippie. So A over H. L'Oreal, what's my A? 15. What's my H, y'all? So 15 over 39 will reduce to 5 over 13. Good job, Jake. And then what's my last ratio? Tangent. How do we find tangent? Tripping on what? Yes, so TOA. So what's the O? 36. What's the A? So 36 over 15 would be 9/5. No, 12/5, right? Is that hard? No, not at all. Like, honestly, one of the easiest things we've done, but you've got to know the saying and you've got to label your sides right. Because if you mess up the sides, even if your saying's right, the ratios will be wrong. Do I need to do another one before I have you try one? Okay, one more. I'll do one more with you and then I want you to try the other one. So what is step 1? Nope, not label. Circle your angle. So listen, did I tell you what theta was in this triangle? So that's why it says or angle A. So we're going to look in angle A right here. So I'm looking at this angle. So I circled my angle. That's step 1. Step 2 is to label your sides, and then you can go do your ratios, okay? So looking at this angle, who can tell me what she didn't label AC. That makes me mad. Make this a 2 just for fun. I don't know why it's not labeled. Oh, bless. That's okay. All right, anyways, circle your angle, label your sides. Which side is the hypotenuse? 12. It's the longest and it's across from the right angle, right? Okay, look at A. It's on the right. That's the angle on the right. So the opposite side is going to be the side on the left. So this is the opposite, which means the adjacent is 2. Very good. So your step 2 is to label your 3 sides: opposite, adjacent, and hypotenuse. All right, let's get y'all talking. Let's get some extra credit. So I'm going to write it like this time, just so you can see the different ways it's written. Sine of A, because A is the angle we're dealing with, right? How do we find the sine ratio? What do we do? Go ahead, Jake. Opposite over hypotenuse. So what would my ratio be? Very good. 4 square root of 5 over 12. Can we reduce that? Oh, be careful. Yes, you can. Yes. Remember 4/12. Those are the whole numbers. 4/12 is just a third, right? So you could write 1 square root of 5 over 3, or you could just put square root of 5 over 3. Good. We've done that before. Simplifying with radicals. All right, good. Jake got his extra credit for the day. Somebody different. It can be somebody online too. What would my cosine ratio be, Soraya? I saw you first, babe. Very good. Adjacent is 2 over the hypotenuse is 12, which would reduce to 1/6. Good job, girl. All right, and then I'm going to talk to somebody online. Can somebody online tell me what my tangent ratio would be? Remember, tangent is opposite over adjacent.
12 over 2.
Ooh, look at Beatty. Be careful. Opposite. What's your opposite side?
Oh, 4 square root of 5.
Okay. 4 square root of 5 over your adjacent side, which is 2. And y'all, what's 4 divided by 2? Good. It's 2 square root of. Very good. Can y'all try C? Everybody can try C? That's a great question. So I had a blonde moment and I realized now why she didn't label AC. I need to go apologize to her later because I was about to be mad. I thought she forgot to label a side. If this is a right triangle, how can you find what C is? Pythagorean theorem, find C, label your sides, do your ratios. I'm going to pause and walk around and help people online. Y'all let me know if you need my help. Don't go anywhere because we're not done. Did everybody get 2 square root of 3? So just to review, 12 breaks down into 4 times 3, and the square root of 4 is a whole 2. So now that you know the C side, step 1, what did you circle? Angle. If you're not circling your angle, you're going to struggle in a second. Circle your angle. I know you're probably like, why do I need to do that now? You're going to need to do it in a minute. Circle your angle. What's step 2? Label your sides. So did y'all put the opposite on the left since the angle's on the right? Did y'all put the hypotenuse across from the right angle? I hope. That's the longest side. And then that means the one that's touching it that's left is the adjacent. All right, I need 3 volunteers. I'm not telling you which order you're going in. I need different volunteers. Haley hasn't gone. Jordan hasn't gone. Evan hasn't gone. Here we go. All right, Jordan, what would the sine ratio of theta be? Square root of 3 over 2 square root of 3. What does that reduce to, y'all? A half. Be careful. The square root of 3s cancel. So this is just 1 over 2. Very good, y'all. All right, Evan, I'm coming to you. You ready? What's your cosine ratio? Good. 3 over 2 square root of 3, adjacent over hypotenuse. Can you simplify that? You can't simplify that, so you can leave it just as is, okay? Is everybody okay with that? Yes? All right. And then Haley, what would my tangent ratio be? Good. Square root of 3 over 3. The opposite side over the adjacent. This is half of your homework. Do you feel like you can do trig ratios? Jake's like, oh my God, yes, like we haven't really done anything. Not bad, right? Okay, this is what I need you to remember when I'm about to show you this next part. What we're doing next comes straight from this. So I don't need y'all freaking out, okay? No freaking out. Every year, like half of my kids will freak out. I'm not doing anything different. Do we understand? Okay, the next part we're doing, we're gonna find a missing side. So here's the good thing about this, y'all. You're not doing all three ratios. You're gonna use what I give you and what's missing to figure out which ratio we need to use. So it's less work, okay? Yes? Okay, perfect. So with trigonometry, you only need to know one side and one angle in order to find the missing parts in a right triangle. People at home, you do not have to write this unless you want to. So we only have to know one side and one angle, and from that, we can find all the other missing pieces. All right, so what we're gonna do, we're gonna decide how the given side and given angle relates to the missing side. Then we're gonna set up an equation using the appropriate trig ratio. And we're not gonna worry about this bottom part. So we're gonna decide how the side and the angle that they gave us relates to the missing side, set up an equation, and use the appropriate ratio. Sound good? It's really not bad. You're gonna wanna really make sure you're paying attention on the first couple of ones, and then I'm gonna turn you loose, okay? So I feel like y'all are gonna be good. Is anybody at home still writing? I'm going with no, since y'all didn't answer. All right, so it says find the missing side x for each right triangle, round to the nearest tenth. Perfect. I'm gonna do A and I'm gonna do D just because they're underneath each other, so it'll be easy. All right, what did I tell you earlier step one was? Circle your angle, very good. Circle your angle, it's right here in the left, right? So listen, I don't need you to label all three sides. I need you to label the one I gave you and the one that is missing. Do we understand? Okay, 18, how does that relate to the angle 22 degrees? It's adjacent, very good. So that's adjacent. How does the x relate to it? Opposite. So I want everybody to think about it. If you have the opposite, Henry, and you got the adjacent, what trig ratio should I use? Ooh, extra credit. Tangent. On acid, tripping, tangent. You got to know which ratio goes with which sides. If you have O and A, you're using tangent. Is everybody okay with that? Yes or no? Okay, so listen. Tangent of what angle? What's my angle this time? 22. So remember earlier, I'm going to flip just so I can show you. On the front, I had you write sine of angle A. The A was in parentheses, right? Or sine of theta. So here we're going to do tangent of what's the angle? 22. So everybody look. Tangent of 22 degrees equals, and then what's my ratio? X over 18, opposite over adjacent. So what are we trying to find? X. How do you get the X by itself? Multiply by 18. If you multiply the 18 over to the other side, that'll tell you what X should be. That's all you're doing. Are we okay? Now, I'm going to keep it real with you. When you get to pre-cal, you'll know how to do trig in your head. We do not teach that in math 2 because this is already enough new stuff as is, so we let you use the calculator. So do y'all want me to show you Desmos or on a graphing calculator first? Desmos, okay. So I'm going to switch to Desmos really quick. Google Chrome. Desmos. All right, so everybody check out Desmos. Remember, it is free. You can get to it on a phone, tablet, computer, anything. When you get to Desmos, we need to type into Desmos 18 tangent of 22 degrees, right? That's what you had written on your paper. That would equal X, correct? I do not recommend using your phone calculator. It's not very nice to deal with. So everybody look, the very first thing you got to do is go to your settings. Make sure your calculator is in degrees, because when we're in math 2, all of our angles are in degrees. You'll learn what a radian is in math 3. So I'm going to change it to degrees. And then everybody watch. I'm going to do 18. Hit the little keyboard. Go to functions. Does everybody see the trig button? That's the first thing that pops up. Where's the tangent? Yep, the third one down. Good. 18 tangent of what were my degrees? 22. That's what X should be. 7.27. Does everybody see that? Not difficult. If you're using a graphing calculator, you do it the exact same way. Change your mode to degrees and then hit that tangent button that my boys on here were talking about earlier. Is everybody okay with that? Are y'all sure? Okay, so we got 7.27. That should be X. So I'm going to share my screen back. We got X equals 7.27. That's your answer. You found the missing side. Can somebody tell me why we can't use Pythagorean theorem to find that side? Good. You don't know what C was. So this is one of your legs. In order to find a leg in a right triangle with Pythagorean theorem, you got to know the other two sides, right? We only knew one side, so you can't use Pythagorean theorem. You've got to use trig. Now, once you find what this side is, if I asked you to find C, could you use Pythagorean theorem? Yes. Are y'all still paying attention? We're almost done, but I got to make sure you get this. Everybody's good. All right, let's do D. So what's your very first step? What should you do first? Circle your angle. Then figure out how the two sides they labeled relate to that angle. So how does X relate? Ooh, good job, y'all. It's adjacent. How does 18 relate? It is the hypotenuse. So think about it. Nobody blurt nothing crazy out. I want you to think about it first. If I have adjacent and hypotenuse, A and H, what am I using? What ratio? Cosine. Don't call it cos, cosine. Yeah, I know you were. Everybody always says cos. It's cosine. So let's set up our equation. Cosine of what angle? 49 equals, good, X over 18. How do you get X by itself? Multiply by 18. So what we want to type into Desmos is 18 cosine of 49. Make sure it's in what mode? Degrees. If you didn't change it to degrees, you're not going to get the right answer. You'll get something crazy. And I'll notice because you'll get really small numbers and I'll be like, was your calculator in degree mode? That's the comment I'll leave in Canvas, okay? You said you got an answer already? Oh yeah, use Desmos. I'm gonna pull it up too. So we're typing in 18 Oh my goodness, she didn't like that. Here we go. 18, I'm gonna go to the trig button again, maybe. Functions, and this time we're using cosine of 49. Did y'all get 11.81? If you round it to the nearest hundredth, like it said? It says what? Are you in degrees? Wait, what? Oh, it says nearest tenth. Why didn't y'all tell me that last problem? My goodness. The paper apparently says nearest tenth. So what would this round to? 11.8. Very good. People at home, are y'all okay with that?
Yeah.
Don't y'all love how they told me that after I did the first one? My goodness. All right, so x equals 11.8. Very good, y'all. How many more do you feel like you need me to do? You do need one more. One more. I don't know if you need the rest. I think one more, and then if you want to try the other ones and get me to help you before you do the homework, you can. Let me make sure I pick a good one. This one's perfect. Let's do E. What'd you say, babe? Yeah, the bottom is for tomorrow. All right. First step, what do you do? Circle your angle. Thank you, L'Oreal. Extra credit. Then what do I do? Label your side. So, Jaden, what do we label the 30? You can tell me the letter. Ooh, is it touching? Be careful. It's opposite. Y'all look, 55 is in the bottom left. 30 is the top right, right? So this is going to be opposite. And then let's see. Who do I want to talk to? Tyler, can you tell me what X would be labeled?
The hypotenuse.
Very good, the hypotenuse. So somebody different. Oh, I'm looking at E, baby. We already did D. Oh no, I'm on E. E. Somebody different for extra credit. Soraya's ready. Soraya, what trig ratio are we going to use if we have opposite and hypotenuse? Don't you call it a sin. Thank you. Sine of what angle? 55 equals the opposite over the hypotenuse. Remember, some old hippie. So it's going to be 30 over X. And let me tell y'all, this is where y'all will mess up. X is not in the top anymore. I'm really hoping you learned in math 1, if your X is in the denominator, before you can get it by itself, you have to move it out of the denominator first. So what's the opposite of dividing by X? Multiply it. So everybody look, I'm going to multiply the X over to the other side. And then to get it by itself, what am I going to have to divide this time? The sine of 55. No, you're trying to get X by itself. So you don't want to move the X again. We're going to move this time whatever's touching X. So we're going to divide by sine of 55. Does that make sense? Yes or no? Are y'all sure? That's where you'll mess up. If X is in the bottom, you have to get it out of the denominator first. And then Soraya, look, baby, we're trying to get X by itself. So you don't want to move it again, because then you're putting it right back in the bottom where it started. You need to move the sine of 55 over, so you're left with just X. Is everybody okay with that? So listen to me. Anytime X is in the denominator, you're going to end up dividing, okay? Did everybody hear that shortcut I just told you? If X is in the denominator, you're going to end up dividing. So what we want to type in the Desmos is 30 divided by sine of 55. So I'm going to switch to Desmos. And I'm going to do 30, maybe. 30 divided by, I'm going to go to my trig functions again, sine of 55. So what should X be rounded to the nearest 10th? Very good, 36.6. How do y'all feel about this? Do you feel like you can do it? What's the hardest part? Solving? You think solving? I think setting it up is going to be the hardest for some of y'all. For some of you, it might be the solving. Just remember, if X is in the bottom, you're going to have to divide, okay? All right, so listen, your homework looks like a lot. It is not, okay? I need you to do each problem I assign so that you are ready to add on to it tomorrow. Sound good? You got 12 minutes. You should be able to get at least half of it done. Does anybody have any questions?